After already going through some of the postulates and theorems that it takes to prove lines parallel, we are going to now use those postulates or theorems to prove those lines parallel. So just as a refresher, corresponding angles postulate, the converse tells us that if the corresponding angles are congruent, then our lines can be parallel by the converse. Another one we have talked about is alternate exterior angles. If I can prove that two exterior angles are congruent, then I can prove that the lines are also parallel. Consecutive interior angles, if I can prove that two consecutive interior angles are supplementary, then I know the lines are parallel. Alternate interior angles, proving two interior angles are congruent, then I can prove the lines are parallel. Remember, all of these are using the converse. Converse proves lines parallel. And perpendicular transversal converse just says if two lines are perpendicular to the same transversal, then those lines are also parallel. So let's go to the back page of our notes since we've already done the others. So we have in our picture, we are given that angle 1 is congruent to angle 2. And we want to prove that line L and line M are parallel. All right, so remember, we always start out with our given information. Angle 1 is congruent to angle 2, and that is given. Well, if I remember back, angle 1 and angle 2 are actually alternate exterior angles. And if alternate exterior angles are congruent, then our lines are parallel because of the alternate exterior angles converse. I always tell people, if you see in your proof statement two lines are parallel, we know we're going to have to use the word converse. So don't forget that word. It's very important. All right, let's try another one that's maybe a little more challenging. I'm given that WX, and I'm going to extend my lines because sometimes when those lines stop, they get a little confusing to me, so I'm going to make it look more like a transversal. So I'm given those two lines are parallel, so I'm going to go ahead and write that in my proof. WX is parallel to YZ. And I also know angle 3 and 2 are congruent. And both of those things are given. Now, I'm trying to get to, I'm going to look at my proof statement. Two lines are parallel, so I know I need to use the word converse somewhere. So I'm trying to get WY is parallel to XZ. I don't have that yet, but that's what I need to get to. So if I would want to make those two lines parallel, there's two different paths we could go down, possibly, to make those two lines parallel. If 1 and 2 were congruent because of corresponding angles, that would make them parallel. Another avenue we could maybe go down is 3 and 4 are consecutive interior, so we know that if they add up to 180, that would make that those two lines parallel as well. So those are two different options we have, and I'm going to erase all of those things that we don't necessarily have yet. So let's see where this proof takes us. So I have 2 and 3 are congruent. So I also have 2 is equal to 3, which is, remember, the definition of congruent angles. And I use that maybe because I might need to use it in an equation. All right, so I'm looking over here at consecutive interior angles. So I'm looking at my orange parallel lines, and I'm trying to see, do I have two angles that are consecutive angles according to my orange line? So just looking at the orange line, Do I have consecutive angles? And where I see consecutive angles, I see angle 2 and angle 4. They both touch the parallel lines, and they are on the same transversal line. So I'm going to say angle 2 and angle 4 supplementary because of the consecutive interior angles theorem. So I used that here, and I used that one on number 2. All right, so I have number 2 and number 3 to use. Well, I know if they're supplementary. I also know that the measures add up to be 180 degrees because of the definition of supplementary angles. So I use number 3. Now I have number 2 that I need to use. Can I use number 2 and number 4? Oh, well, I can maybe substitute where number 2 is. I can put number 3. So that's where they got number 5. Measure of angle 3 plus the measure of angle 4 equals 180. And I'm going to use substitution. All right, let's look back up here. 3 and 4, I now know are adding up to 180 degrees. Well, that's a good sign because remember what we talked about before, that could be a possibility. Well, if they equal 180, that means that they are also supplementary. Because of that definition of supplementary angles. Well, if 3 and 4 are consecutive interior angles to our parallel lines or our lines right there, that now tells us that those two lines are parallel because they are consecutive interior angles. And remember, because I'm proving lines parallel, I need to use the word inverse.